Have you ever looked up at the night sky and wondered what's up there? Beyond the stars and planets we all know, there are thousands of satellites. But one of them is extra special and very, very mysterious. It's called the X-37B, and it belongs to the United States Space Force, a part of the Pentagon. Think of it as a robotic mini-space shuttle. It goes up into space, does secret jobs for a long, long time, and then comes back to Earth all by itself. What it does up there is a big secret, and that's why so many people, from scientists to curious citizens, are fascinated by it. It's like a ghost ship sailing silently through the ocean of space. The mystery surrounding the X-37B is what makes it so captivating. The Pentagon rarely shares details about its missions. We know it's a test platform, a place to try out new ideas and new technologies in the harsh environment of space. But what exactly is it testing? Is it deploying small satellites? Is it spying on other countries? Is it practicing how to fix or disable other satellites? Because we don't have the answers, people's imaginations run wild. This secrecy leads to a lot of speculation and debate among experts around the world, making the X-37B one of the most talked about objects orbiting our planet today. It represents a new chapter in space exploration, one that is cloaked in military secrecy. The X-37B looks a lot like NASA's old space shuttle, but much smaller. It's only about 29 feet long, which is roughly the length of a school bus. It has a small payload bay, like a tiny truck bed, where it can carry experiments or other secret cargo. Unlike the space shuttle, which needed a crew of astronauts, the X-37B is completely autonomous. It flies itself from launch to landing. This robotic nature allows it to stay in space for years at a time, performing its tasks without needing any people on board. It is a remarkable piece of engineering that combines the best of a spacecraft and an airplane into one sleek, reusable vehicle. So why all the secrecy? The U.S. Space Force says the program is important for our national security. By keeping the missions classified, they prevent other nations from learning about the advanced technologies being tested. This could include new ways to protect our own satellites or new methods for gathering information from space. In an age where space is becoming more and more important for communication, navigation, and defense, having a vehicle like the X-37B gives the United States a unique advantage. It's a way to stay ahead in the ever-evolving domain of space, ensuring that our access to it remains secure for years to come. Getting anything into space is a big challenge. The X-37B starts its journey just like any other satellite. It is carefully placed inside the nose cone, or fairing, of a powerful rocket, such as a SpaceX Falcon 9 or Falcon Heavy. The rocket then blasts off vertically, pushing the X-37B faster and faster until it breaks free from Earth's gravity and enters orbit. Once it's safely in space, the fairing opens up and releases the spaceplane. From there, the X-37B unfolds its solar panels to generate electricity from the sun, and its long, quiet mission begins. This launch process protects the vehicle during its intense climb through the atmosphere. Once in orbit, the X-37B becomes a true spaceplane. It uses its solar panels to power all its onboard systems and experiments. One of its most impressive abilities is its maneuverability. Unlike most satellites, which are stuck in a fixed path, the X-37B has an engine that allows it to change its orbit. It can move to different altitudes and change its trajectory, making it very difficult for anyone on the ground to track its exact location or predict where it will be next. This ability to roam around low Earth orbit, an area from about 125 to 465 miles up, makes it an incredibly flexible platform for whatever secret tasks the Pentagon has assigned to it. The program has a fascinating history. It wasn't always a military project. The idea for the X-37B actually started with NASA back in 1999 as a way to test new technologies for reusable spacecraft. A few years later, the project was handed over to DARPA, the Pentagon's advanced research agency, before finally moving to the U.S. Air Force and now the U.S. Space Force. The first X-37B flight took place in 2010, and since then, there have been several missions. Each mission has lasted longer than the one before, with one staying in orbit for an incredible 908 days. That's almost 2.5 years. This shows just how reliable and durable these robotic vehicles are. Perhaps the most amazing part of the X-37B's journey is its return to Earth. When its mission is over, the spaceplane fires its engine to begin its descent. It enters the atmosphere, just like the space shuttle did, using its wings and control surfaces to glide through the air. It then lands horizontally on a runway, just like an airplane. This reusability is a game changer. Instead of building a new spacecraft for every mission, the Space Force can just inspect, refurbish, and relaunch the same vehicle. This saves a tremendous amount of money and time, making access to space more routine and affordable for testing cutting-edge technology. The most recent mission, known as OTV-8, which stands for Orbital Test Vehicle 8, blasted off on a powerful SpaceX Falcon 9 rocket in August 2025. This launch was another exciting moment in the X-37B's history. For this particular mission, the Space Force announced a few of its goals, giving us a rare peek behind the curtain. While most of the mission remains classified, we know it is focused on testing a whole new suite of futuristic technologies that could completely change how we operate in space. This mission is all about making our space assets more resilient, efficient, and secure, ensuring they can work even when faced with new challenges. One of the coolest experiments on this mission involves something called a quantum inertial sensor. That sounds complicated, but the idea is pretty simple. Today, we rely heavily on GPS for navigation. But what if the GPS signal gets jammed or isn't available, like in deep space? This new quantum sensor uses the principles of quantum mechanics to measure the X-37B's movement, its speed, rotation, and direction, with incredible precision, all without needing a signal from the ground. It is the most advanced sensor of its kind ever tested in space, and it could one day help future spacecraft navigate autonomously to the Moon, Mars, and beyond, a truly revolutionary step for exploration. Another groundbreaking technology being tested is laser communications. Right now, most satellites use radio waves to send data back to Earth. But radio waves can be intercepted, and they can only carry so much information at once. Laser communications, on the other hand, use a focused beam of light to transmit data. This is much more secure and can carry a huge amount of information. Think of it as upgrading from a dial-up modem to super-fast fiber optic internet. On this mission, the X-37B is testing its ability to communicate via laser with a large network of commercial satellites, like SpaceX's Starlink, creating a robust and high-speed data highway in space. These missions are becoming more and more ambitious. The previous mission, OTV-7, landed in March 2025, after spending 434 days in orbit, continuing the program's track record of long-duration flights. With each new launch, the Space Force pushes the X-37B to do more and stay in space longer. The fact that the recent OTV-8 mission was launched on a powerful Falcon 9 rocket also suggests it might be carrying heavier experiments or is being sent to a higher orbit than ever before. Each flight builds on the knowledge of the last, steadily expanding the capabilities of this mysterious and powerful spaceplane. So, why does the Pentagon pour so much effort into the X-37B program? The answer is simple. It provides a unique advantage in space. In today's world, our way of life depends on satellites for everything from weather forecasts and banking to navigating with our phones. Protecting these satellites is a top priority for national security. The X-37B serves as a one-of-a-kind testbed, allowing the military to experiment with new technologies in a real space environment before deploying them on expensive satellites. It helps them figure out what works and what doesn't, reducing risk and paving the way for a more advanced and secure space infrastructure for the future. The X-37B's special abilities make it incredibly valuable. Its reusability means that the Space Force can conduct experiments much more frequently and affordably than if they had to build a new satellite each time. Its ability to maneuver and change orbits makes it a flexible platform that can respond to new needs or test technologies in different space environments. This combination of reusability and maneuverability is rare and sets the X-37B apart from almost every other object in orbit. It represents a shift towards more dynamic and adaptable space operations, where spacecraft are not just passive objects, but active tools that can be controlled and repurposed as needed. Looking ahead, the X-37B and vehicles like it are changing how we think about space. For decades, space was seen as a place for peaceful scientific exploration. But as more countries develop their own space capabilities, it is also becoming an arena for strategic competition. The X-37B is a clear sign that space is now a critical domain for national defense, just like land, sea, and air. Its missions, though secret, are helping to write the rulebook for this new era. It forces us to consider important questions about what is and isn't acceptable behavior in orbit, sparking international discussions about the future of space security. Ultimately, the X-37B is more than just a mysterious space drone. It is a symbol of our expanding presence in the cosmos. It bridges the gap between exploration and security, pushing the boundaries of what is possible with robotic spacecraft. While its missions may be shrouded in secrecy, the technologies it is perfecting, like autonomous navigation and laser communications, will likely benefit everyone one day, both in space and here on Earth. The silent flights of the X-37B are not just about military strategy. They are about shaping a future where humanity will operate more freely, safely, and effectively in the final frontier. And that's something worth getting excited about.